Hey mathematicians, we are going to math it up today. We're going to be doing some factoring. We're going to be taking monomials and factoring them out of binomials and trinomials. All right, let's get started. This is part 2. There is a part 1 that has much simpler problems to do. So if you'd like to start there, go back and find the same video that just happens to say part 1. But these are more complex problems, more exponents involved, more variables involved, and a little more complex. So again, factoring and distributing, we can distribute, but then the inverse of that would be taking a factor out and factoring. So we're going to look at both of those to start off with. And then also I want to make sure that we all recall these things, and that a monomial is one term, a binomial like a bicycle with 2 wheels is 2 terms, trinomial like a tricycle with 3 wheels is 3 terms, and then you'll also hear the term polynomial. And poly means many, so that just means many terms. So we can use that for larger expressions. All right, so let's go ahead and start by distributing, and then we're going to reverse it and do some factoring. So we're going to take this monomial and we're going to distribute it into this binomial here with 2 terms, one here and one here. So let's go ahead and begin. We have 12, 3 times 4. We have 2 x's here, 2 more here. So that gives us 4 x's altogether, and then I have a y. So I have multiplied this term by this term, and here's my product. Now I'm going to go to the second term here, a positive 3 and a positive 3, so that's 9. 2 x's here, so x squared, 1 y here, 2 more here being multiplied together, so that becomes y not to the second but to the third. So if my job is to distribute, this would be my result here, which gives me this binomial. But let's go ahead and reverse this process and let's factor this. All right, so we've got to think about these terms. I have one here and I have another one here. And what's the largest coefficient and the largest number of x's and y's I can take that are common to both terms. So just to make this really clear, I'm going to turn this into single factors here. So 12 is the result of 2 times 2 times 3. 4 x's would look like this, 1, 2, 3, 4, and 1 y. So that is 12 x to the 4th y in terms of factors. And then we're also going to have 9 would be 3 times 3, and then times x, that's x squared, and then times y times y times y is the 3 y's there. And there you have it. So we're only going to do this one time. I wouldn't expect you to do this every time, but this will help us to see how this is working. And let's look at this. So in terms of our numbers, the only factor we have in common here is a 3. Okay, so I know I'm going to be able to pull a 3 out, and again, we know what the final result should be here. Then I'm looking for x's. Well, I have 1 x in common, I have 2 x's in common, and that's it, because there are no more x's here. So that would be the greatest number of x's I can pull out of there. And then I have 1 y here, 1 y here, I have 2 more here, but I only have 1 in common. So that's how I get my greatest common factor. And we will see in a moment these remaining factors are going to tell me what I need to multiply by. So we can use this to tell us, or we can just work it out this way. So if I need to turn a 3 x squared y into a 12x to the 4th y through multiplication, I will first need a 4. I will need 2 more x's. These two need to turn into 4, so I need 2 more x's, and the y is already there. So you can see here's the 4, and here are the 2 x's. All right, and if I want to turn a 3x squared y into a 9x squared y to the 3rd, I need to multiply, they're both positive, so I need to multiply by a positive 3. That'll get me my 9. The x squared is already here, but I have 1 y here. I need 2 more to make y to the 3rd. And again, here it is. There's that 3. Here are the 2 y's, and I said 2 and I wrote a 3. So hold please. There we go. There's the 2 y's. So again, that's factoring out, and I can always check my work by multiplying through. 3 times 4 is 12, 2 more, that's x to the 4th. Here's the y. 3 times 3 is that positive 9, 2 x's are here, 1 y here, 2 more here, that makes y to the 3rd, and I'm good to go. So that is the factoring. And again, if you want to go back to part 1, same idea, much simpler problems, and that might be something you want to do. So here we're going to distribute this in, and then we're going to reverse and go ahead and factor it back out. So I have 2 times 2 is 4, 1x here, 3 more here, that's 4 x's being multiplied together, 1 y here, 1 here, that's 2 y's being multiplied together, and I've done this. And now I'm going to go ahead and distribute here. 2 times 5 is a positive 10. I have to be careful about negatives. I have an x here, I have an x here, that's x squared, and then I have a y here, no y here, so just 1. And now I'm distributing this 2 xy here. 2 times a negative 3 is going to give me a negative 6. I have the 1x here. I have a y here and 2 more here. That's y to the 3rd. All right, so we have distributed. Now we're going to do the reverse process. We already know what our answer should be here, but let's go ahead and try it. So let's think about, I'm not going to factor everything out again and make the individual factors, but let's try to think about it. We know it's 2, but 4, 10, and 6, the largest number coming from there as a factor is going to be 2. I have 4 x's. I have 2 here, so I have 2 in common, but I only have 1 here, so I need what's common to all 3. There is only 1 x common to all 3 terms. Y's, I have 2 here, 1 here, and 3 here. I only have 1 in common. Even though these are bigger numbers of y's, I need to know what I have common to all 3, and it's only 1 y. So that's it. Now I'm going to multiply, find what I need to multiply this by to get back here. So I have 2, I need another 2. 2 times 2 is 4. I have 1x here, I need 4. So I need 3 more to get to 4. I have a y here, I need 1 more to get to 2. And there I have it. 2 times 2 is 4. X times x to the 3rd is x to the 4th. Y times y is y squared. All right, carrying on. I have a 2. I need a positive 5. That makes 10. I have 1x. I need 2. Here's the other one. I have 1y. I only need 1y. So I don't have to do anything there. I can just leave that 5x as is. And now I need to turn this 2 into a negative 6. That's going to be a negative 3. 2 times negative 3 is negative 6. I have an x. I need an x, so I'm check on the x's. It's already here. I have 1 y. I need 3, so I will need 2 y's here. And of course, when we multiply back through, we're going to get this. We can check here because we've done this backwards and forwards. We see that our answer is indeed correct. Great. All right, and just to make sure we have this down, we're going to do another couple of problems together. This can be a little tricky, and you have to pay very close attention to what you're doing. So let's try another one here. So now I have a couple of numbers here. 2, 3, 6, 2, 3, 6. I'm only going to be able to pull a 2 from here. So we'll start with that 2. I have 2 x's here. I have 3 here. So I do have 2 in common. Y, I can pull that y out of there. And now I'm going to try to get back to where I was. So I will need a positive 3. 3 times 2 is 6. I have these x's here. I have the y. I don't need anything else here. 2 times 8. Positive 8 is a positive 16. I have 2 x's here. I need 1 more to make 3. And here's my y already. So that should be it. I made my parentheses a little too big here. There we go. So let's check our work. 2 times 3 is 6. X squared y, that's it. All I had multiplied by was the 3. 2 times 8, that's a positive 16. X squared and 1 more is x to the 3rd. Here's my y, and I have a match, so I'm good. Okay, let's try the next one. And again, you just want to go through slowly, carefully, make sure you're taking out a big enough number. Only take out the common variables to all 3 terms like we're about to do, or both terms if you're in a binomial. And really just be careful about the numbers. All right, so we have a 9 and 18 and 27. So hopefully that feels like something you know in terms of what can be pulled from there. All right, so we can start our work. So 9 will be the number, the coefficient. I have 4 x's, 3 x's, and 2. So I only have 2 that are common to all 3 of these terms. These are 3 separate terms. I only have 2 x's in common. Even though I have 4 here and 3 here, I only have these 2 in common across all 3 terms. How about y's? I only have 1 y, 2, 1. I only have 1 y in common. Okay, and again, if it helps you to do this and get all these spelled out, if that helps your thinking process for each one, then do that. But if you can think it through without that, it's a lot less work. So 9 is already taken care of. I don't really, 9 times 1, but that's, again, that 1 is understood. It's one of those invisible numbers. If there's nothing that we can see ahead of a variable, we know the coefficient is a 1. It's just one of those numbers we don't write down if we don't have to. All right, so the 9 is there. I need 2 more x's. So I need 4. The y is there. So I'm all set with term 1. I need a positive 2 to make 18. 9 times 2 is 18. I have 2 x's here. I need 3, so I need 1 more. I have 1 y here. I need 2, so I need 1 more. Now 9 needs to turn into a negative 27 through multiplication. That's going to be negative 3. And we have 2 x's here. We have 1 y here. So that's it. I'm all set. So let's take a moment, multiply through, make sure we get our original problem. That will tell us that we've done our work correctly. 9 times 1 is 9. 2 x's, 2 more is a total of 4 x's being multiplied together, and here's a y that also needs to be part of it. Okay, now I'm going to distribute here. 9 times 2 is 18. 2 x's, 1 more is 3. Y and a y would be y squared. 9 times negative 3 is negative 27. I don't have any variables here, but I have these. All right, let's check this. 9x to the 4th y, 18x to the 3rd y to the 2nd, negative 27x squared with the y, and we are check and check. So now we're at check and correct. This is where you get a chance to stop the video, do the problems on your own, and then check them, and if necessary, correct them as you watch me work through these. So go ahead and stop the video, and we'll see you in a couple of minutes. Okay, welcome back. Hopefully you have factored these, grabbed that greatest common factor, and arrived at your answer. So let's see here. We have a 9 and a 21. I'm thinking 3 is the largest number we can take from there, the largest factor. I have 1x here, 2 here, so I only have 1 in common. 2y's here, 4 here, I have 2 in common. All right, so I have taken a 3xy squared from the 2 of these, and let's see what's left over. So 3 times 3 will get me that 9. X is already represented. The y is already represented. 2y's, 2y's. So now I can go here. 3 times 7 is going to give me that positive 21. X, 1 here, 2 here. I need 1 here. 2 y's here, 4 here. I'll need 2 more y's here. All right, let's go ahead and multiply through to check our work. 3 times 3 is 9. Then I've got my x multiplied by those 2 y's. And that is finished. Distribute here. 3 times a positive 7 is 21. X times x, x squared. Y squared times y squared is y to the 4th. 2 y's here and 2 y's here. And if that matches, and it does, I'm good. So hopefully that's the answer you have right here for your work. All right, just to give myself a little more room, I am going to erase that to handle this larger problem. And let's look here. So I'm going to start with my coefficients. Looks like there's a 5 in common there. I have 3 A's, 3 A's, 2 A's, so I have 2 A's in common. 1B, 2 B's, 1B, it's only 1 B in common. All right, now I'm going to use multiplication to turn this and this into this. So I need a 2 to get back to that 10. 5 times 2 is 10. I have 2 A's here, I need 1 more. And I have my B already represented there, so I don't need anything more. I need to turn a 5 into a 15. Positive 3 will do that. I have 2 A's here, I need 3. 1 more. I have 1 B here, I need 2. So I need to add that B. All right, 5 to a positive 25 is 5. 2 A's, 2 A's, check. B, B, check. Looks like I'm all done. Let's check our work by multiplying back through. 5 times 2 is 10. A times 1 more A would be A to the 3rd. And here's my B. It's part of this. And it looks like I have a match. 5 times positive 3 is positive 15. 2 A's, 1 more is A to the 3rd. A B times a B would be B squared. Let's see if I match. Check. 5 times positive 5 again is 25. A squared B. Because there's nothing here but the 5. And that matches as well. And I have been successful factoring this trinomial. All right, so all that's left is the math it up on your own. You have 2 different problems here to handle. Here's a binomial, here's a trinomial. Looks like there's a little extra space here, but just ignore that. That's all one term. And go ahead and do these 2 problems on your own. Go back to the video if you need a little more support. And thank you so much for joining today and advocating for yourself. And as always, peace, love, and pie to all. Thanks for watching. Bye-bye.